So y equals 45 degrees. Because it comes from this triangle. The sine of 45, the opposite over the hypotenuse is this, which
Oh, that
changes
ends up
into
turning
this.
into that, okay.
Yes. Or if I pick this 45, same way, opposite over hypotenuse this. Now sometimes they want the answer in radians, and I believe that's true with this, so how do we change 45 degrees into radians?
45 times pi over 1.
Times pi over 180. Otherwise, you guys need to have these charts written down in your notes so you can flip back and look at them during the test. This comes out to be pi over 4. This is the same way. The sine of what equals negative 1? Now this one's a little different because it's not going to come from your 30, 60, 90 or 45, 45. This one comes from your unit circle sitting here. So this is 1, 0. This point is 0, 1. This point is negative 1, 0. And this point is 0, negative 1. What makes the unit circle weird is you really kind of have to think of it as being a triangle here that's 1 degree backwards but 0 degrees up. And the sine is the opposite over the hypotenuse, which if this is 0, my hypotenuse is 1. And this, however, though, is a positive, right? I don't know how to draw this to help make sense of that one yet. But I do know in your little charts in your book, because I flip back to them and look at them often.
Yeah, that'd be pretty cool if I could get from this side to go to this side.
If you look at page 508 and 509 in your books, those are some green charts that I would highly recommend putting on your notes pages for your test. If you look at it, sine of x is 1 at pi over 2. Well, what kind of pi over 2 would make that a negative 1?
A negative pi over 2.
Mm-hmm. So this is negative pi over 2.
Oh, yeah, definitely. See, genius. But it's like you smacked me in the head.
That was really deep.
It wasn't
No,
very
really, Chad, that was like your word was my job.
Just
They were done.
that last paragraph, because I couldn't think of anything else. I was like, that was the only choice that I remember. So I was like deep.
TK, at least you had a favorite toy.
What?
At least you had a favorite toy in life.
You have a favorite toy?
I don't need video games.
Okay.
That's a toy.
No, it's video games.
Hey,
I wanted to
hey.
quiet.
What do you say? Hey, really?
And these answers are also because on page 541, the inverse sine function has these restrictions. X has to stay between negative 1 and 1, and y has to stay between negative pi over 2 and pi over 2. So that little purple chart on page 541 is another thing I would put in your notes. 541, yes. Now, when we go to look at this, this means the sine of y has to equal negative 3. if our y is here, this is my x. Does that fit in my boundaries? No. So this is undefined.
We could.
And,
You were laughing.
TK. What?
So can you hear me?
Yeah,
Just speak up.
That's how he knows.
Isn't it?
No, that's how you hear.
I'm trying not to yell so I don't my voice doesn't overpower the camera right now. So I have a very quiet voice, and probably if you're watching this video later, you can hear use my signature. Hey, that's Michael. Stop up here. I've been recording for about 6 minutes, 8 minutes.
Okay, look on page
Boom, roasted.
543.
I can't.
And focus spin on things.
Page 543.
I'm there.
There's another chart in there. It shows the boundaries for y equals sine x, but then it shows you the boundaries for the inverse of sine, which I just put up there. Inside there, it shows you the boundaries for cosine. So notice how those are different. Put those in your notes. I don't expect you to memorize those, but I do expect you to know how to look at your notes and remember which boundary goes with what. Same thing for the arctan. They have different boundaries there also. Okay, for the cosine of -1, this means cosine of y equals -1. Cosine is your adjacent over your hypotenuse, right? Okay, so your adjacent over your hypotenuse leads back to this situation here where we have -1 comma 0, because we have a triangle that really is going up 0, but has a distance here of 1, which also has a radius here of 1. And since this is -1, it'd be over 1. So in radians, how many degrees does it, or how many radians does it take to get from here over to here? Like, what do we label that axis normally? 180, but in radians. So it should be pi. So the answer for that one is pi. This one wants tan of y to equal the negative square root of 3 over 3. Do we have a triangle that gives us the square root of 3 over 3 normally?
63.
The 30, 60, 90 has the square root of 3 in it, and that's the one we're gonna need. So remember, the square root of 3 is here, 1 is here, and 2 is here. Tangent is opposite over over adjacent. So the tangent is 1 over the square root of 3, but that leads into that answer, right? Because we then rationalize. So we know this is going to be a 30-degree angle, but here's what we need to figure out now. What quadrant is it going to be in? This is all students take calculus. So it either has to be in 2 or in 4. But we have to keep in mind the boundary of that, and it says that y has to be between negative pi over 2 and pi over 2. So we need this to be like a negative 30 degrees so that we keep it between the pi over 2 and the negative pi over 2. What is negative 30 as radians though? How are we gonna figure that out? Pi over 180.
Got it.
So this is gonna be a negative pi over 6. The tan of y equals 0. So this is saying that my adjacent over my hypotenuse has to equal 0. Well, how's the only way that's going to happen?
The adjacent 0.
Y has to equal 0.
No. You didn't like my photo.
Okay, the next part, you need to break out your calculators.
Ah.
Okay, stop recording. Still recording.
Oh, yeah.
Hey.
There's someone calculator. I have no calculator. Oh, you smart over here has 2 calculators?
There's like this.
No, I don't feel safe with using my hands.
Okay, so the first thing is it wants you to evaluate these in radians. So make sure your calculator is in radian mode. And then evaluate the tan inverse of negative 7.92.
You know how to do grading more on these things?
No.
You know how to do it on the other one?
Sometimes the buttons also don't work, that's what I was gonna tell you.
Right here, the
Oh.
degree,
Yeah.
you go over to rad and hit enter.
I don't mind about mine.
Where, what?
I hope I did it right. What's the answer?
Sometimes you honestly have to just.
Oh,
As hard as you can.
What's the answer?
The
Oh.
answer for this is a negative 1.445198325.
That's a good deal.
So if you did it correctly, you should have gotten negative 1.445198325.
Got it. Yeah. Where's degree?
I would have had it if I would not push the times button.
What is this quit button do? Quit.
Why can't you stick with
Nothing.
It's like, on a Windows computer where you push Control Alt Delete and your computer crashes.
Oh, it's just a back button basically.
Oh. We have
Be like-
16 minutes of raw uncut footage right now.
You can vote tonight? I'm just having to take it up, so I'm gonna vote. Or then just stop me?
You can vote.
I can show you the world.
You can. I'm blind.
Yeah, right.
Trump is gonna be over.
I'll let you hear the world.
And deaf.
Yeah.
You can't speak.
That's how you do it.
Yeah, I lost my hearing when I was a couple years old, so now I speak a little.
Every year.
Yeah.
Every year at an eligibility vote.
You probably sound like Taz the Tasmanian Devil. Just blah, blah,
Unless I just
blah,
so
blah.
official like sheet that has everyone ever been on one.
Okay.
Okay, I'm pausing this.
Jurisdiction.